In class example 1.31, we explore stretches on a piecewise function. We are given the graph of y equals f of x and asked to construct a mapping rule in order to sketch the graph of g of x equal to 1/2 f of x. We note that the 1/2 is out in front of the f and is not with the x directly. This means it is the a parameter value and not the b parameter value, and as such is a vertical stretch factor. Remember also that though a b value requires us to determine the reciprocal value, an a value does not. So the 1/2 will in fact be the vertical stretch factor. As such, our mapping rule will be that xy becomes x and 1/2 y. We could also write 0.5 if you prefer. The effect of this is that each point on the graph will have its y coordinate multiplied by 1/2. Or divided by 2. And so we will see all the points above the axis, the x-axis, lower a little bit, and those below will raise a little bit, and the x-intercepts will remain the same. In this question, we're asked to determine the location of any invariant points. We're going to simply say on the x-axis. If the question asked us for the coordinates of the invariant points, we would have to use some of our Math 10 skills. For example, if we looked at the line segment joining -1 and 4 to 2 and -6, we could determine that it had a slope of -10/3. And with those points, we could then put that into y equals mx plus b form or slope point form, and from there could calculate the x-intercept. Similarly, for the line segment joining 2 and -6 to 6 and 2, we could determine the slope and using a point generate an equation and then find its x-intercept. However, that goes beyond what we're talking about here. Now, when asked to compare the domain and range of f of x and g of x, it's important to note that the only transformation applied was a vertical stretch. This means no horizontal transformation happened, and therefore the domain will be unchanged. We see that the leftmost point of f of x, which is the blue graph, or excuse me, the black graph with the blue points, the leftmost point had an x-coordinate of -5, and the rightmost point had an x-coordinate of 6. Therefore, its graph has a domain of -5 to 6, and g of x will have the same domain. Its range, however, does not look at the end points, but rather the highest and lowest point. So our highest point on the graph has a height of 4, and our lowest point has a height of -6. Notice in both the domain and range, we've used brackets that are rectangular and turned inward because we are including those values. An outward turned bracket in interval notation would only occur where we had a hollow point. So again, because the domain is unchanged, it will remain as -5 and 6. Our range, however, underwent a vertical stretch by a factor of 1/2. So even without looking at the transform graph, I know that if I half the -6 and half the 4, which were the y minimum and y maximum value in our range, I will find the new range of -3 to 2. We could also do this by looking at the graph and seeing that the lowest point occurs at a height of -3 and the highest point at a height of +2.